Let's add our fluid widget to the JiGui. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, we added toggle button, and that was a widget dedicated to a button. However, if you recall, we were extending ourselves from another widget that was in vanilla. This time, we are doing things differently because we don't have anything in vanilla that is close to the concept of a fluid container. So we need to write everything from scratch and do it ourselves. To do that, we create a class and we call it fluid widget, and I will call this one normal maybe because I want to think about a tiny one, or I will add a normal in the front or medium. So medium fluid widget. No, let's keep it as fluid widget because I can combine the sizes later as I need to. Now this class needs to implement two interfaces to become a widget. One is drawable and it comes from Net Minecraft Client GUI. The other one is the widget class. So it comes again from Net Minecraft Client GUI widget. And now I need to implement methods, and the methods as you see is render, set x, set y, get y, get width, height, and for each child. After that, it doesn't yell at us to implement any constructor because we are not extending from another class, so we don't need to have dedicated constructor. Now, to do things here, I can have two different approaches. The first one is to send in the fluid storage itself and handle everything inside here using that fluid storage. For example, from fluid storage, I can get the type of the fluid, I can get the amount or the max capacity of the fluid container, or alternatively, I can use another way. And the other way is that I don't care about container. I just care about the type of the fluid, the amount, and the capacity, and I can get them from constructor or anything else. However, the problem with that is that they change during the time. So the fluid type in a tank may change, or the amount, or even the capacity of the tank can be changed. In other words, we would be in trouble if we don't use the fluid tank. We can still go with the second approach, but then in our screen handler or even a screen renderer, we need to constantly update these values using method calls. And I am not happy with that approach. The less headache we have, the better. So we start with getting the storage. Now for fluids, of course, we will have dedicated videos in the main tutorial series all about fluids. So I will move forward thinking that you already know about fluids. So we have single fluid storage because guess what? We are not drawing multiple fluids at the same time. This class is not related to such a thing. So a smeltery like Tinker's construct is not being possible using this widget. If we need to, then we can handle it in a different way. Here we are having one slot dedicated to one type of fluid. So single fluid storage, and we call it fluid storage. Yes, I'm happy with that. Then we have a few things. As you see, it's suggesting the x, y, width, and height for the widget, but we want something else. If you are aware, the fluid inside Minecraft can change its color based on the biome it's in, and the color will be tinted based on the biome. So to mimic that inside our fluid GUI, we need to know which biome it is in. Instead of biomes, actually, we need to know the position of the container. We will have either a block pose itself, or I don't know, maybe a supplier. Having a block pose means that we are sure that the fluid container doesn't change place at times. So for example, we don't have a minecart that has a fluid container in itself and it's not moving around. Okay, so we have a dedicated block sitting in the world and it's not changing its position. However, if we want to use this fluid storage widget for global purpose, for example, we may have a minecart that contains a fluid storage. Now that minecart will move around and the position will not be static. Again, the same thing that we talked about, the fluid storage amount and type and etc. can be applied here. We don't want to constantly update that position value ourselves each tick. Instead, if we add a supplier of position, then we can just say that, hey, you can retrieve the value of the position from this method call and it will update itself automatically. So we will say private final supplier of block pause, and we call it position supplier. Yes, why not? It looks like we are finished. However, moving back to our textures, the X, Y, width, and height is related to the background container. We will add two markers. Now, if you want to, you can merge one of these with the texture and get done with it. But in the main tutorial series, I already showed that it's not a good thing to do that, because the moment the fluid goes up, it will cover the markers and the markers won't show up in front of the fluid. And I want to make sure that the user can change these textures as they want to. In other words, other than the background X, Y, width, and height, we need the markers X, Y, width, and height. So I will call these background X, background Y, background width, and background height. Okay. Then I will have another set, and this one will be marker X, marker Y, marker width, marker height. Do we need anything else? I don't think so. Yes, we can add fluid widgets that are using larger background and marker sizes, the smaller ones, but the default one works for most of the time. So I will keep it as it is. And now we need a constructor. The constructor should add everything into the class because they are final and they shouldn't be changed during the time. We have it, but in previous video you saw that we want a builder. So before diving into the rendering, get X, get Y, and stuff like that, I will say public static class, and we call it builder. And in builder, for sure, we will have a build method. So that's the boilerplate. Okay, here we will say public fluid widget, and we call it build, and that's it. I will remove it empty right now. Before I even continue, I should mention that there is a plugin for Java that we can use, and it's Project Lombok. Project Lombok lets you assign something like annotations with builder, setter, getter, and things like that. However, although I installed Lombok, I don't use it that much because, in my opinion, using Lombok, you don't have control over anything. That's a little bit of a warning for me. Although those who know Lombok very well argue back that Lombok is not harmful, there is nothing wrong with using Lombok. And for example, if you say @builder somewhere, I'm not sure if it's on the class or on the methods. As I said, I never used Lombok that much, but at some point it should work. And for example, for a param, you can have @setter, and it's not showing up because, as I said, Lombok is not being added to the project right now, or @getter, and these should add setter and getter methods for you. Okay, if you want to use Lombok, Lombok, go and take a look at YouTube videos. They explain things much better than I can, and you can use that. However, for things like builder, especially builder, I'm a little bit hesitant on doing that because using Lombok means that you don't have control over anything here. The builder will be a default builder that sets these params with some provided parameters on the method calls. But as you saw in our toggle button, we can add as many helper method calls as we want to. For example, on the fluid widget, I can use a marker size call, and for example, I use, I don't know, a method call like use detailed marker, okay, and will accept a flag as true or false. And then I will have a method call that says use defaults, and it will assign the default textures, default values here. Using Lombok, you don't have that option. Before adding the builder, I will come back to the builder at last. We need to do things here. Other than the constructor, let's leave the render empty for time being. At the very end, I will add a method that says protected void draw tooltip, and this one will accept the draw context, that is context, int mouse x and int mouse y, and again I will implement it later, and we will start adding the body for each one of these. For each child, actually we don't do anything, so it's an empty body. We don't do anything there. Although I may not need it, but I will prefer to have this fluid storage as a getter. And yes, I can totally use Lombok there, but get fluid storage that returns public single fluid storage, and that's it. For the get height, we return height, or actually background height. For the width, we return background width. For y, we return background y, and for the x, we return background x. Now, take note, although we have a marker texture that we will use on top of the background, the main x, y, width, and height methods are checked checking the global size of the whole texture and the widget. So we are saying that, hey, widget is this size, and yes, we will have things inside of it, but this is the biggest size of the widget that we will have. So if you have a widget that will draw something outside of the background, for example, then yes, you want to increment and decrement the size as you need to. But here we will draw everything inside of this background's borders. So that's the x, y, and z, and x, y, width, and height that we will return. Now for set y, we say this dot y equals to y, and for set x, we will say this dot x equals x. Now the errors show up because x and y can't be final. So I will copy these, them there, remove the final, remove it from here. And again, don't forget, we have background here. So this dot background x, this dot background y equals to y, okay? Then we have the render method. Now the render method is the heart of everything. If you recall from my main series, we have this gem cleaner screen render, and there we were drawing a fluid as a temp solution on top of the screen renderer. The whole thing is the same render call, and here we will draw the background, draw the fluid, and then draw the marker, okay? So in this particular case, we were not drawing the background because the background was part of the main container's background. However, we need to add that here, and actually now it reminds me that we need two more parameters that we need to add to the constructor, and that is private final identifier, and we can call them, I don't know, background texture and the marker texture, okay? And we will ask for those textures, I don't know, before the supplier. So this is identifier, background texture, identifier, marker texture. And let's break it so that we can read them better, like so. And of course, here we say this dot background texture goes to background texture, this dot marker texture goes to marker texture. In render method, the very first thing that we want to do is to draw the background, okay? And for that, we will use a screen utils dot draw texture using the context, and then the texture will be background texture, and then we will have the background X, the background Y, U, and V. And here is a problem. We will need these U and V values, then background width and background height. Let's add those U and V values. So again, they will be fixed values. So we will have background U, background V, marker U, and marker V. Now, normally, if you use my textures, the U and V should be 0 and 0. However, as I said, I'm not sure how will people use this. Maybe they will add their own sprites inside a sheet and, add it to the system. They want to change the U and V. So we have that ability, and we should give them the ability. So again, we have background U, background V, marker U, and finally marker V. And of course, now I need to add them. So background U, background V, marker U, and marker V. Here we can use them. This will be background U and background V. Now, guess what? We will use the same code, but instead of background, we will use markers. So we will have marker texture, marker X, marker Y, marker U, marker V, marker width, and marker height. We did effectively draw the background and the marker. Now we need to draw the fluid. So we will say that the fluid itself, call it fluid, equals to the fluid storage variant get fluid. That's correct. Then we say long amount equals to fluid storage that get amount. Then we say long capacity equals to the capacity of the fluid storage. Then we want to get the bar height. Now, bar height is actually the internal of the background. Let me use Photoshop to help you. Now, as you see, this is the bar height, okay, and it's 61 when the whole background is 63. So we have the background height, okay? Now here we say int bar height equals to the math.round amount divided by capacity multiplied by background height. But here, as I said, we need to reduce 2 pixels from the height because that is our border. I'm not sure if this makes sense for every texture or not, because the problem here is that people may have different textures for their container as the background, and that texture may have extra borders around itself. So I will add it here. I don't have any other way to handle it. So we will have a private final int, and that is the background border width. And again, I will accept it somewhere. Yeah, here int background border width, and finally I need to assign it here, and this will be the background border width multiplied by 2. That's exactly what I want, because the width will be this. It's 1 pixel, and here is 1 pixel, and the border here is 1 pixel, border here is 1 pixel, although again I'm not using any hard-coded number, so I will remove that. Okay, so instead of this, can I go with the fluid background fluid height? It would make sense, isn't it? Because as I said, all I care is the size of the internal place. I don't care about borders here. So background height, instead of that, I will use background fluid height. That will make sense now. So no matter how you change the borders, you will know the height of the pixels that you want to draw the fluid. Now that we have this bar height, it means that we know how high we want to draw the bar, and it's time to get the fluid sprite and everything ready to draw it, because drawing it is actually easy. We will say screen utils dot render tiled sprite, and here we will have a context, a render layer colon colon get GUI texture. Then we want the sprite that we want to draw. We don't have it, so it's still texture. Then here is the X. So the X, oh wait, you know what I'm thinking about? I'm constantly coming back to this border stuff. Okay, so for example, if the designer makes the decision that, you know what, I want to have 3 pixels on one side, like so, and the rest will be the same. Now this will be the new X. Same goes on the top. We don't know what is the texture that they want to do. So I need to handle things very delicately and very precise. So instead of getting background for the name, I will call it fluid. And beside the height, I need the width, I need the Y, and I need the X. And I need to add them here. So let's copy this guy, the paste there, replace the marker with the fluid name. Removing that, fluid X, fluid Y, fluid width, and fluid height. Okay, finally placing this guy with the fluid height. Now here, we want to draw the fluid in the X, Y, so fluid X, fluid Y, but here's the problem. We can't directly go with the Y, because if we draw it like that, we will go from the top border. Fluids and energy bars and stuff like that has a very special context. The context is that we should draw from bottom to top. Now, if you know anything about Minecraft drawing system, it will draw from top to bottom, and we need to trick it so that it draws things properly. To do that, we need to use that bar height and reduce the Y by bar height so that we go down. Then we will use the width, so fluid width. Now again, for the height, we are tricking the system and we are not using the fluid as the comment here suggests. We'll use bar height. Finally, we will have our color. For color, let me see what is the suggestion. It's color helper that format floats with 1F for alpha, and then we will get red, green, and blue from our code. And this color helper is from Minecraft util math, and that's the whole thing. So let me break it so that we can read it better, like so. Okay, this is the call to draw the fluid. Let's put few lines of comments so that we know what we are doing here. This is the widget background, this is the fluid, and finally this is the marker. To get these values, the still image, the red, green, and blue, we need to handle things. Of course, I could provide some private fields on the class and then use a method call here to assign them. The only thing that would be changed is that it would make the things neater. However, I can use regions. Why not? So region, fluid, render handler params, and end region. So I will use this trick to compact things later. And here we will say that, hey, we want the fluid render handler, and we call it fluid render handler equals to fluid render handler registry.instance get. For this fluid that we are using, this will retrieve the handler for the fluid inside the registry. Then we say if the fluid render handler equals to null or the amount is 0 or below 0, we return, because we don't want to draw the fluid. However, we want to draw this marker first and then we return, because if we return right here, we will not draw that marker. So if we are empty or anything else, just draw the marker and return, because we don't want to go deep inside any calculations. We don't have any fluid in the container. Here we say block pause equals to the position supplier, and we get the position from there. Then we want the fluid state equals to the fluid dot get default state. Now this means that if we are water, we get the default state of a water. If we are lava or any other custom fluid, we get the default states from them. Then we want the word. Now here is the trick. This is the only time that you can use this code, and not the context, because the context doesn't have the client, but we say Minecraft client dot get instance, and then we call the word on that. As I said, this is one of the few places that we can directly get the instance of a Minecraft game like Minecraft client or Minecraft server, because we are sure that we are on client side, we are rendering things, and this call will only happen from the screen renderers, and the screen renderers are always client side calculations. So yes, we can use the Minecraft client.get instance.word. Another place maybe is the key bindings and checking for the key that is pressed or not, because that happens client side again. Now that we have the word, we can start getting our sprite. So sprite, and we call it steel texture, equals to fluid render handler dot get fluid sprites, and yes, that's the whole code actually. So what does this code do? As I said, the fluid render handler is the handler for the fluid inside registry. It has everything related to that fluid. So from there, we can get the sprite of the fluid inside the game. For this word and position, because as I said, fluids in the game can change their tint based on the position in the word. And we say that, hey, this is the default state that we want. And then we have an array, because get fluid sprite returns an array of sprites. The index 0 is the still image. It's just water being still, for example, or still lava in its place. The index 1 is the flowing fluid, so flowing water or flowing lava. In our case, because we are drawing it inside the container, and also because of the way that this render tile sprite works, we want to draw the solid sprite for the fluid, so we get the index 0. And that solves this steel texture. The only thing is that red, green, blue, because as I said, fluid can have tints. So we want to get the tint. We will say int tint color equals to, again, from the fluid render handler, we want to get its fluid color inside the word and position for the default state. This will look into the word and the position and returns the tint color. Now we can get the red, green, and blue. So we say float red equals to the tint color bit shifting toward right, and this may look a little bit of confusing, but if you know, we have R, G, and B, and R is actually the third number, so we'll have something like this, FA, I don't know, 8. This will be the number inside memory, okay? And this is the red. The middle one is green, and then the blue. Now, if I want to get the F alone, I need to move it 2 bytes toward the right, because the first byte is 8. When I move the whole value toward the right 8 bits or 1 byte, I'm dropping the 8. Then another 8 bits or a single byte will drop the A, and I finally have the F. And then I will do an AND with this FF, because, well, guess what? This value is not just F. It's FF, for example, AA and 80, something like that. Now, this 80 value is just 1 byte of information, or 8 bits. This AA is the same, this FF is the same. So if I have F0, for example, FF means 255, okay? And I want to see how much from 255 I have. For example, if I AND it with 255, it will return, I don't know, 126, for example. This will convert that tint complex color to isolate its red compartment and then convert it to an integer instead of a byte system. Finally, I divide it to a float value of 255 to get a value between 0 and 1. Okay, we handled the red. Now we want the blue. The blue is actually 8 bits of shift, because as I said, the blue is the middle one. If we move 8 bits toward right, then we are dropping that 80. But here's the thing, now we will have something like this, F0 AA, because we did drop that 80 at the end. And this is why we are ANDing it with FF, because now when we are ANDing it with FF, basically we are dropping this, because FF is 00 FF. And ANDing it with this value means that, hey, 0 and F means 0, and 0 and 0 means 0. A and F means A and F means A. So the result will be 0, 0, A. So we effectively dropped that red compartment now. We isolated the greens. And finally, when it comes to the blue, we don't want any bit shift. We just do the AND to isolate the blue color and then convert it to a range of 0 to 1. And finally, we can draw that fluid widget. And this is the calculation that you can have at any time in any shape or any form that you need in any class to just get a fluid sprite and its tint out of the system to do whatever you want with it. I don't know what you may want, because one of those examples is drawing that fluid inside the world using custom renderers, and we'll work with that in future. However, I don't want to dissect this into a helper method, because that helper method then needs to return a tuple system, and I don't want to make things overcomplicated. This is just a method call, and instead of a method call, I can just copy this and paste it inside one more helper class and get done with it. If I so need to, then yes, I can convert this into a helper method, and we will take a look at that later. But for time being, we are okay and we are cool. So we finished our render. However, this only draws the background, the fluid, the marker. If we move the mouse inside the container, it doesn't show us the amount of fluid we have. So we will say if mouse helper dot is mouse over. Now here we want the mouse x, the mouse y, and then the x, y, width and height. And the x, y, and width and height is the background. We can use the fluid one. I will use the fluid one. If our mouse is right on top of the fluid drawing, we want to draw the tooltip, and that's the whole thing. Now we can move down and finish with this draw tooltip, and then we will go back to builder, because that's the heart of this whole thing. Okay, for draw tooltip, I will say again, we want a fluid equals the variant and get fluid, and then we want the amount, so long amount equals to amount, long capacity is equals to capacity. Now I need a text, but before that, let's do things here. We say text renderer, and this is text renderer equals to Minecraft client. Again, we can get the instance and the text renderer here. Then we say if fluid equals null or the amount is less than or equals to 0, then return, and I will move this one below this check, because if we don't have any amount or anything, we don't want to draw any tooltip there. Now we want to get a list of texts. We'll say a list of text from Minecraft text, and we call it texts equals to list.of, and here we want two elements. The first element will be the name of the fluid maybe. So here we say text.translatable. Let's see what it gives us. Field.getDefault state, get block state. Yes, that's it, exactly it, because we want the fluid state, and then from the fluid state we want the fluid block, and then we want the block inside the registry, and from there we want the translation key so that it will use the translations from the Minecraft itself. Now this one says literal because it doesn't need any translations. However, this is where I want to dissect things. So I will say int amount in millibuckets, yes, equals to that, and then this is the capacity as millibuckets. So int capacity in millibuckets is equals to that, but I'm not done with this. If you add these two values here, you will see something like, I don't know, 100,000 from a million millibucket, and that is not containing any thousand separators. For example, it will be something like that. And this is hard to read. Of course, at the end, we will have MB. This is really hard to read. However, if I add few thousand separators like this, it's much more readable. Or alternatively, if I say 100K from 1 million, it's even much better, isn't it? Now, it depends. Do we want this format or this format? I will go with this one. I can have both of them. And the thing is that I added a helper method thanks to Direwolf. Of course, I had to convert some of those helpers from Forge to Fabric, but this one was not that harmful because it is basically Java thing, okay? And as you see, this formatted is adding 1,000 separators, and it works both for the integer and float if you want to. But with suffix adds that KMGTPE values if you want to. So 100K, 1M and things like that. So I can use both of them. Let's go with formatted, okay? So we say string amount equals to string helper from my library, not the Minecraft ones, dot formatted. And here we say amounts in millibuckets. Then we have another string and we call it capacity text. Equals the same thing for the capacity. And finally, I will add them here. So it's amount text and here is the capacity text. Now that I have these, I need an extra parenthesis here. Yes, I can finally draw the tooltip because I have the list of text that I want to draw. I have the renderer, the mouse X, mouse Y, so I can just draw it. I will say context.draw tooltip on the renderer with the list of texts and mouse X and mouse Y. And that is our draw tooltip. Now, up until now, this part is thanks to Tortiworty, okay? Because the heart of this thing is this render tile sprite, and I got it from his repository. This section, however, is totally different from his implementations, and this section is, again, different from his implementations. And because I changed the parameter system, now I need to change things in the builder. So I will do this. I will get the things as the annotations for myself on top of the class, but then on the render, I will add annotation thanks to, and here we want to say that he's a YouTube user actually, although he's a Discord user too. But I prefer to use YouTube because, well, guess what? You can find him on YouTube better. Turti, come on, can't find the name. Yeah, not GitHub user, but he's a Discord user. I can add both of them. Yeah, so you can find him on GitHub and Discord, and this shows up when you move your mouse on the render method. You see that thanks to on top. It's a nice thing to have actually. Okay, so that's the render and our overrides. Finally, we go to the build method. Now, build, as you guess, needs everything that we have on top. So I will copy these things. I will come back down and I will paste them. And before that build call, we need to handle things. First things first, the only thing that is actually, I don't even want this one to be final, and you will see why in a few seconds. Now, for the supplier of blog post, I will go with the inline initialization because inline initialization is interesting. It's just null. But others, I will keep them as they are. So I will add a constructor that accepts enough. Okay. Inside this constructor, by default, do I want to have water or lava? Nothing. Because if you are not producing anything, it means that we will fail on render because at the start, this will be null. So I will do a null check here. We will say if the fluid storage equals null or variant equals null, just return. We don't have anything there. And this will help us solve any wrong move on the user side. Now that we have this, we need to add different method calls that return the builder. So public that returns builder. Here we want to assign each one of these. So if you'll ask for a fluid storage and it will return this, I will copy that one. Are you smart enough to suggest things? X, Y, width and height for the background. Yes, that's nice. Then we will have the marker. That's nice. Then we have the fluid one. Hopefully, yeah, that's the texture one. Nice suggestion there. I was thinking how I can add that U and V thing inside the marker and background, but this is much better. So we only left with fluid one. So fluid. By the way, if you are wondering what is suggesting this code, I think it's Google Copilot. I'm not sure. I have the AI assistant on the tutorial version, but I'm not sure. Then we have the supplier, and as I said, textures are being fine. So position supplier. Okay, let's see. So far, we added the fluid storage, then the background width, height, and these two actually. Then we have the marker ones. Of course, we will have the fluid ones. So let's get that up. Now, instead of texture, and then these are background, marker, and fluid. Can you suggest something for, come on, maybe? So background coordinates, marker coordinates, and fluid coordinates. Maybe. I think it's better this way. I was thinking about rectangles. So for example, background rect, marker rect, and fluid rect. I think I prefer rect just because it makes sense to have X, Y, width, and height. And the name is shorter. Okay, then we have the texture, and position supplier. So let's see. We cover the texture, and when we are covering the texture, we are covering the U and V. So texture, UV, and then position supplier. We already covered everything. Okay, now I want to have a default. So we say, no, not thanks to public builder, use default values. All we are sending here is just the fluid storage. Okay. Now here we will say return this dot. Guess what? We can call ourselves just like that, but I will take a look at these values. So background rectangle is 0 by 0. Now I need to use Photoshop, and it's 18 by 63. So 18 by 63. The marker rectangle, I will use this one. So the marker rectangle is 16 by 51. However, notice that this is not the X and Y. Things will change, and I will show you. The fluid rectangle is 16 by 61, and then we go for the textures. Now instead of doing it this way, I have constants that we can use. So I will use widget textures dot fluid storage background, and then for this one I have widget textures dot fluid markers. Now here's the thing, which one is that? The big one is the storage marker big, and the small one is the storage marker small, and this is the difference, is the gap between the markers. So the small one I want, fluid markers small. Now the U and V means the coordinates inside the textures. So for the small, for example, U and V will be 0, 0. However, the X and Y is different. The X and Y for the fluid border is 1 and 1. So for the fluid, X is defaulted by 1, Y is defaulted by 1. Now for the texture, it will be here, because take note, this single red pixel should be down here. So it will 1 and 6. So for marker, X is 1, Y is 6. And this is exactly how you define the default values. So we send in the storage, we call the background rect, the marker rect, fluid, and let's get the position. I'm not sure if I want to, yeah, but let's do it. So we have a position supplier. No. Supplier of be smart, there we go. No. So I will say dot pause supplier with the supplier. That's one overload. The other overload, actually, do I want to use another overload here? I was thinking about removing one or both of them. For example, this is a fluid storage. Then I will have another one that accepts nothing, like so. But then the fluid storage would be null, or the supplier for the position would be null. That doesn't make sense. So the only thing that we will have is just this. And by doing it, we already have everything that we need to finally build our fluid widget. So we return a new be smart, new fluid widget with the fluid storage, the background X, background Y, width and height. Let's move this to a second line. Let's see if I have the same in the constructor up in here. No, let's move it in second line. Okay, so background, then the marker, then the U and V. So then the marker, then the U and V, then the fluid, then the textures. Now I want to move the fluid before that U and V thing, and I need to do it right here too, like so. So we first get the rectangles, then the background UVs, and that's it. Do I want to have any U1 that uses rectangles for the background, marker, and float? I honestly don't think so. That should be the whole thing. So this finished our fluid widget, and our fluid widget is actually ready to be used. At any time, we can say fluid widget equals to fluid widget dot builder no dot new fluid builder dot, and then use default values on, I don't know, a tank that we have, and the, for example, be colon, or we are calling it from somewhere. Yes, be colon pause or get position. I don't know. Let's get pause, and that would be this whole thing. And is dot build, and that would work actually. This would be a widget that will draw fluids from this tank using this block entity's position at any time. And now we can add that widget to any renderer that we want. As fancy as that and as simple as that. So that's our fluid widget. In the next video, we will come back and talk about another widget, and actually it's really similar to fluid widget. Instead, we don't have a fluid tank, but we will have an energy storage. And we can use that energy storage to get the amount and everything else. However, I may differ from it. We will take a look at that in the next video. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.